Hey guys, Mr. Backerberg here. In this video, we're going to look at solving some application problems. So in our first example, we've got two cars at an intersection, and they leave at exactly the same time. One car is heading north, and the other car is heading west. Now, sometime later, they were exactly 100 miles apart. The car heading north had gone 20 miles further than the car going west, and we want to figure out how far each car had traveled. So we're going to call this point right here, that's our intersection. And we've got one car heading north, and the other car going west. And if we connect these, this ends up making a right triangle. So we know that the cars are 100 miles apart. So this distance, this dotted line in here, is going to be 100 miles. Now, as far as the other sides go, I'm going to let this side going west, I'm going to call that X. And then we know that our car going north, that distance is 20 miles more than the car that was going west. So this is going to be whatever that X value is, but then plus 20. Now, as we're looking at these sides of this right triangle, we can use the Pythagorean theorem to help us out. And remember, the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse of our right triangle. So I could plug in that 100 on the right-hand side to get 100 squared. Let's say that this bottom side, this x, is our a, so we're going to go x squared. And then we've got this x plus 20, let's call that our b, so we have to go x plus 20 squared. Now this x plus 20 squared might be a tricky piece in there. We are actually going to have to FOIL that out because squaring something means times itself. So we've really got an x plus 20 times another x plus 20. So if we start FOILing this out, x times x is x squared. X times 20 is going to give us 20x. 20 times x is going to give us another 20x. And then 20 times 20 is 400. So on the left-hand side of this equation, we're going to have x squared plus another x squared plus 40x plus 400 equals, now on the right-hand side, when we take that 100 and square it, we're going to get 10,000. Now we can combine these x squareds to get 2x squared plus 40x plus 400 equals that 10,000. Now because we're dealing with a quadratic, we're going to want to get this equal to 0. So I'm going to subtract that 10,000 over to the left-hand side. So then we should get 2x squared plus 40x minus 9,600 equals 0. Now having that 2 in front of that x squared might make things a little tricky, but we can actually get rid of that if we take everything in our equation and divide it by that 2. So then we end up getting x squared plus 20x minus 4,800 equals 0. And then we can actually factor this out. So to get x squared, we're going to need x and x. Now, this might be a little bit tricky, but we need numbers that are going to multiply to negative 4,800, but add up to 20. And it actually ends up being a positive 80 and a negative 60. Now that we have this factored out, we can take each factor and set it equal to 0. So the x plus 80 equals 0, and the x minus 60 equals 0. If we subtract that 80 over to the right-hand side, then we're going to get x equals negative 80. And if we add that 60 over to the right-hand side, we're going to get x equals 60. Now we have to remember that x is representing the distance that this car traveled going west. So if we think about that x value of negative 80, we can't measure a distance as being negative, so we're going to ignore that one. So we're going to look at that x value, the distance that car went west, that's going to be 60 miles. So I'm going to label that in my triangle over here. So this distance right here is 60 miles. And then this other one, this is x plus 20. But if x is 60 and we add 20 to that, then this distance over here is going to be 80 miles. So the car going west went 60 miles, and the car going north went 80 miles. So in this example, we've got a rectangular pool in a park that is 20 feet wide by 30 feet long. And the park gardener wants to plant a strip of grass of uniform width, so the same width around the edge of the pool. She's got enough seed to cover 336 square feet, and we want to figure out how wide that strip of grass should be. So we've got our rectangular pool in the park that is 20 feet wide by 30 feet long. And we're going to plant a strip of grass that's the same width around the outside of our pool. But we don't know how wide that should be. So we're going to call that width, we're going to call that x. So this distance from the edge of the pool to the outer piece of the grass, we're calling that x. And this distance going up from the edge of the pool, again to the edge of the grass, that distance is also going to be x. It's the same width across and up and down. And that's actually going to be the same in this green rectangle all the way around our pool. So I'm going to label all of those with x's in here. Now that actually changes how big our rectangle is. So initially we talked about this width as being 20. But we added x on the left-hand side, and we're adding x on the right-hand side. So really, this distance is that 20 feet, but then we're adding 2x to that. And the same thing if we talk about the length. It initially was 30 feet, but then we added x going up, and we added x going down. So this is going to be 30 plus 2x. Now we're talking about area, and remember, area of a rectangle is length times width. Now we know that we've got enough seed to cover 336 square feet. So that's actually going to be our area. So I'm going to plug that in on the left-hand side, 336. Now the length is going to be that 30 plus 2x. And the width is going to be that 20 plus 2x. But we have to hold on for just a second because there's one thing that we haven't accounted for yet. We're only seeding the area around the outside of our pool. We're not seeding the actual pool itself. So right now we're finding the area of this entire large rectangle, but we're going to have to subtract off the area of the pool. So if I take the length times the width, if I take 20 times 30, then that pool has an area of 600 square feet. So whatever we get in here, I need to subtract off the 600 square feet from the pool. Now I'm going to go ahead and FOIL out that stuff inside of parentheses. So we have our 336 equals, now 30 times 20 is 600. If I take 30 times 2x, that's going to be plus 60x. And if I take 2x times 20, that's going to be plus 40x. And then 2x times 2x is going to be plus 4x squared. But then we have this minus 600 accounting for subtracting off the area of the surface of the pool. Now with this positive 600 and this negative 600, those are going to cancel each other out. So we've got 336 equals, and I'm going to rearrange the right-hand side. I'm going to pull that 4x squared up to the front, so it's 4x squared. If we combine these x's, 60x and 40x is going to give me 100x. We've got this x squared in here, meaning that we're dealing with a quadratic equation, so we want to get this equal to 0. So I'm going to subtract this 336 over to the right-hand side. So we get 0 equals 4x squared plus 100x minus 336. Having that 4 in the front is going to make things tricky, so what I'm going to do is divide everything in this equation by 4. So then we should get 0 equals x squared plus 25x minus 84. And then this is actually factorable. So to get that x squared, we're going to need a couple of x's. We need things that are going to multiply to negative 84, but add up to 25. And that's going to be a positive 28 and a negative 3. Now that we have this factored out, we can take each factor and set it equal to 0. So the x plus 28 equals 0, and the x minus 3 equals 0. We're going to subtract that 28 over to the right-hand side, so we get x equals negative 28. And I'm going to add that 3 over to the right-hand side, so we get x equals 3. Now remember, x represents the width of this strip of grass, and we can't have a negative width, so it can't be that negative 28. So the strip of grass should be 3 feet wide. That's going to be it for this video. Thanks for watching.